So these are some real numbers. We talked about gravity on Earth's surface is 9.8 meters per second squared. On the moon is actually 1.63 meters per second squared. Now, considering average male mass for the countries of Chile, Germany, and USA, you'll notice that in the USA, we take Wiener Schnitzel more seriously than they do in Germany. Okay. Part A, I want you to organize your answers as you calculate the weights for these people from these countries for the Earth and the Moon. So here's what I got, and notice a few things. Remember, we use the formula weight is equal to mass times gravity. We know that Moon's gravity was 1.63 meters per second squared. We knew that Earth was 9.8 meters per second squared. And it was just a matter of multiplying the mass by the gravity. Okay. Notice that these are, you're thinking, how does somebody weigh 848 pounds? No, 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 no. These are newtons. How does gravity affect the weight? Now you have Earth and the Moon, right? So obviously on the Earth, people weighed more because the gravity was more. So if you have more gravity, expect more weight. If you have less gravity, less weight. Now this would explain a lot because they say that you are quote unquote weightless in space, right? You're not massless in space. You have mass regardless of where you are and what conditions you're in. C, what happens to an object's weight as it gets closer to the Earth's core? What happens as you get further away? We talked about what happens when you're at the beach versus when you're in Denver versus when you're on Mount Everest versus when you start flying away from the Earth's surface and its atmosphere. So what happens is as you get further away, gravity becomes less and less to the point where it becomes quote unquote non-existent. If the gravity gets smaller, then the weight gets smaller. The closer you get to the Earth's core, then the stronger you're going to feel that pull. Magnitude. So magnitude, you've heard of that word before, right? Like the earthquake was a 7.2 magnitude, right? Or the hurricane was category 4. Magnitude is just strength without direction, right? You don't know what direction that the earthquake was going, but it was a magnitude 7.2 earthquake. So in these problems here, you have a bunch of forces, right? They actually have directions, but we're interested in the magnitude. We're actually interested in the strength. Each of these have a 3 and a 5. And let's go ahead and consider which of these has the least magnitude for the acceleration. In other words, if you were just to not even think about all this technical stuff and just look at the 5 pictures, which one of these would move the easiest and the fastest if these arrows represented two people acting on the same block? You probably said this one because they were both working in harmony with each other. And you would be right. This would be the greatest acceleration. Now, if we went ahead and took this guy right here and we just went ahead and kind of like a backwards clock, right? We went ahead and just moved them a bit. You're going to notice that this is still going to move in the general direction of this direction, but it won't be as quickly as this one here. So this would be number 2. And then continuing that reversal, this is number 3. And then we get to this one, number 4. And we know for a fact that this would be the least. Because you have a positive and you have a negative, right? This 3 is canceling out this 5 to the point where it only becomes 2. See, on this one down here, you were pulling with a force of 8 newtons total combined. They were both going in the same direction, so they added. But in the one up here, they're in opposite directions and they're countered each other. They're unbalanced nevertheless. So it's 5 minus 3 gives you a total of 2 going to the right. So A is definitely the one with the least acceleration because it has the least force acting on it. For this summary, I want you to consider the following. If you were given the mass, how do you calculate the weight? And if you were given the weight, how would you calculate the mass?